This is my presentation of the constant velocity lab. So the purpose of this lab is to calculate the position of an object at set time intervals when moving at a constant velocity. In my video, the object that I used is a tennis ball. Now, the following concepts or equations are going to be used: Newton's second law, the position update formula, the velocity formula, and the velocity update formula, which is also another form of Newton's second law. Now, Newton's second law, which is force equals mass times acceleration, shows that the F net equals 0 throughout the entire experiment. The position update formula was used to determine the position at every time interval. The velocity formula is used to determine the initial velocity, and the velocity update formula is used in the code but not necessarily during the experiment. So the procedure of this lab: materials required, in my video at least, is a tennis ball and a recording device. And the procedure is to push the tennis ball in a straight line across a flat surface and record the motion. Then you have to import that video into Tracker, adjust the start of the video to begin with the motion, and track the center of the ball at every time step. Transfer this data to the Excel sheet and you can use it to compare to the model that you have created computationally. So as a preview of the results, the object speed is 0.847 meters per second. Now I will show you the video that I created. Now this is the code that I used to derive a model. The file time was 0.7007 seconds, and we have the velocity update formula, which was mentioned before, and it also includes the position update formula under a while loop that repeats till the file time is concluded. The velocity is updated each time one iteration occurs, and then that velocity is then input into the position update formula to determine a new position. Now I will show you a run through of the code itself. So this is a run through of the code, and I'm going to run the program. And as you can see, it has a position versus time graph that is extremely linear, and it has a constant slope, which means that the velocity versus time graph is a constant line, and that was actually at 0.847. This means that the acceleration is 0, which proves why F net is also 0 throughout the entire experiment. Now here we have the experimental position versus the model position. The object speed is 0.847 meters per second, and the time that has passed is 0.7007 seconds. Now the position that changed is 0.565 meters. You can see that the position has some variability in it. As you can see, the experimental position and the model position are slightly different. The lines are very similar, but they're not exactly the same. And this could be due to the fact that the experimental position actually takes into account like friction and other forces, which causes variability, while the model position does not do that, and it just sets the values that are provided to the computer. Now the two lines have a relatively constant slope as the position versus time graph is linear, and this means that the velocity is constant, which means acceleration is constant. And F net is 0 as well, according to Newton's law of force equals mass times acceleration. Now, theoretically speaking, here are some two questions. So what if you were to switch axes? Well, what would happen is the velocity and position would just change signs. Now, since the ball is moving towards left, if we go back to our comparison slide, now the ball would actually be moving at a negative 0.847 meters per second speed, and the position would actually be negative 0.565 meters because the ball is moving leftwards. Now, what does all of this mean? So, I personally do not think it is possible to determine all the push and pull factors of the observed experiment to show why F net is equal to 0, because there are so many different forces. There's friction force, air resistance, and there's non-negligible forces like drag that you need to take into account. The environment also matters, because if you put it under a table or on gravel versus like smooth hardwood or near like a fan, there are so many factors that affect how the ball moves and which forces are acting upon it. it is hard to determine at what point specifically that all the push and pull factors create that F net equals 0. But in conclusion, for future experiments, if I were to do this lab again, I would probably try to create a code where I can include other forces that are acting upon the ball, such as friction and air resistance, and this would make the model more similar to the experiment position, and this would ensure that there's less variability and also make it more realistic. Now, thank you so much. Have a good day.